Thanks for joining me at Student Nurses Success. Today's video is going to talk about the immune response. Remember, you can find a link to the maps in the comments section. Let's get started. Let's begin first by talking a little bit about immune response. The purpose of the immune response is really to protect the body from infection and disease. The immune response includes recognition, activation, attack, and memory pieces. It is a coordinated response and it involves both the innate immune system and the adaptive immune system, both of which we will cover in this video. I'd like to first begin by talking about the cells of immunity and what's important in immunity. Within the myeloid cells, and if you remember, myeloid cells are cells that are born in the bone marrow and stay in the bone marrow. The myeloid cells include the red blood cells, the platelets, the monocytes and macrophages, and the granulocytes. Now, the red blood cells we know remove carbon dioxide and breathe oxygen and nutrients to the tissues. And we know that baby red blood cells or immature red blood cells are known as reticulocytes. So that's important for immunity because you have to be well nourished and you have to have good blood flow. Platelets are helpful in forming clots. We know that our monocytes and our macrophages are important because they engulf foreign material and they are the first to arrive. They are part of what we call the innate immune response. The innate immune response is non-specific. It actually will go after anything, whether it has memory or antibodies or not. So it's always circulating through the body, looking for pathogens or foreign invaders. Now, granulocytes include neutrophils, eosinophils, and the basophils. Again, the granulocytes are a part of the first responders. Neutrophils are important in fighting infection. And what we see is sometimes in infection, we start to see an increase in the number of neutrophils. And when we start to see this increase in immature neutrophils, because we'll start just putting them out, whether they're mature or not, when we see this increase in immature neutrophils, we know that an infection is present. We sometimes call this a shift to the left. Now, eosinophils are important in allergic reactions and fighting parasite infections. They also help control inflammation. So those will go up in those situations. Basophils are also part of inflammation and they contain a lot of histamine. So we would see those in times of inflammation and allergic reactions as well. Our other cells of immunity include the lymphoid cells. Now, lymphoid cells actually are born in the bone marrow, but then they leave the bone marrow. Some mature in the bone marrow, some mature out in the lymph system, but basically all the lymphoid cells leave the bone marrow eventually and are out in the body in our lymph system, which is everywhere. Our lymphoid cells include T cells, B cells, and NK cells. Now, NK cells are non-specific and they're part of our innate immune system. They'll kill and attack anything. So, although they're lymphoid cells, they are part of the innate response. They're non-specific. Our T cells are what we call cell-mediated immunity. They include our CD4 T helper cells and our CD8 killer cells. The CD4 T helper cells are important in communication and activation of our B cells and the CD8 cells. So the CD4 cells recognize infection and they will actually go and call for help for the CD8 cells and the B cells to start making antibodies. So they're important step in the middle. The CD8 cells directly kill and attack cancer and infected cells. All of our T cells are part of our adaptive immune system or our memory system. Now, B cells produce antibodies and they remember prior antibodies. So once they've been exposed, they can cycle up the production of antibodies. If they have memory, meaning they were exposed to it prior, they can cycle up the reproduction of those. They're part of the adaptive immune system as well. One of the things that we can do is measure antibody titers. Antibody titers can give us an indication if someone has immunity to some type of infection. IgG will increase if there has been a past infection and you have antibodies for that disease, or if you've been vaccinated for that disease and have made antibodies. IgM will be increased, indicating a current or a recent infection. So if you want to check to see if you have immunity to something, you want to check your IgG titers. Now let's talk about the immune response. The first step in the immune response is really your epithelial barriers. These are our first barriers that pathogens come across. These include our skin, our mucous membranes, secretions and tears that maybe trap or stop bacteria or pathogens from entering the body, and even our microbiota control some of this. The next step in the immune response is the activation of the innate response. The innate response is nonspecific, meaning it'll go after everything, whether it has seen it before and has memory of it or not. We call this the mononuclear phagocytic system. It is always on guard. It is always circulating through the body. It goes out additionally if barriers are breached and pathogens gain access to the body. It sends chemical messengers back that a pathogen is present to call up the other helpers in the adaptive immune system. The mononuclear phagocytic system also phagocytizes foreign pathogens, so they gobble them up. So when they run into them, they gobble them up right away. They can distinguish self from non-self, but they are not specific to certain antigens. They'll just kind of gobble up anything that is foreign. And they start the inflammatory process, which we know infection causes inflammation. The third step is the adaptive response. This is what we call our acquired immunity. The adaptive response includes T cells and B cells. Now, these T cells and B cells migrate to the lymph and wait to be called when the innate system's chemical messengers send out a message. It does take them longer to respond, so they're not immediate like the innate system is. T cells are what we call cell-mediated immunity. They interact with antigens. We know the CD4 T helpers communicate and call for the B cells to make the antibodies, and they call the CD8 cells to come out and kill. The CD8 killers will go out and attack foreign bodies. Now, the B cells are what we call humoral immunity. They are what make antibodies. What happens with antibodies is that antibodies will bind to the foreign pathogen or antigen. So this is this picture right here. You have antibodies that are attaching to the antigen and will destroy the whole thing. When the antibody attaches, it will remove the antigen from the body. Now, the B cells does take more time, especially if they have to make antibodies. If they've never seen it before, it's going to take them several days to make the antibodies. However, if they have seen the antigen before and they may already have some antibodies ready to go, there's a much quicker response if there's that memory. Now let's talk about the types of immunity. We have active immunity and passive immunity. Active immunity has two steps: natural active immunity or artificial active immunity. Natural active immunity means that you contracted the disease naturally. Okay, so it's natural. You just ran it, you got the chickenpox or you got the virus. Once you get it naturally, your host now makes its own antibodies and it will keep memory of those and make them again when needed. So that is your immunity to keep. In most cases, we keep it for a long period of time. Artificial active means that we gave a vaccine to the host. And remember, a vaccine stimulates an antibody response or antibody production. So it's maybe a piece of a dead pathogen, and the body then makes antibodies for it and stores those. Since the host has made the antibodies, they are now have the ability to remake them when needed. In most cases, vaccines confer a decent length of immunity and antibodies. So active means that you made it, you get to keep it. Passive is a little different. Natural passive means that you receive the antibodies in a natural way from the mother, usually through the placenta or breast milk. The problem is that passive immunity means that the antibodies will not stay for a period of time. And so these antibodies are short-lived. Since you did not make them yourself, you were given them, you do not maintain a copy of how to make them again. Artificial passive means that you received actual antibodies from another source. Usually it's immune globulin. But because you did not produce those, the host did not make those antibodies, they are short-lived and will not be sustained long term. You do not have the map or the plans to make those antibodies again. So passive immunity is always short term, active immunity is for a longer period of time. There you go. Remember to subscribe and like our videos in order to get all our new content.